Hello students, in today's lecture I am going to start the description of 8085 microprocessor pin configuration. As I have already told you in my previous lectures that 8085 microprocessor is a 40 pin IC. So as you can see in this slide, the pin configuration of 8085 microprocessor, that it has 40 pins. So I'll be telling about each and every pin in detail. So basically this 40 pins of 8085 microprocessor is classified as follows. We have power supply and frequency signals, then data bus and address bus pins, then control and status signals pins, interrupt signals pins, serial input output signals pins, DMA signals pins, and reset signals pins. To start with, power supply and frequency signals pins. So under this classification comes VCC, VSS, X1, X2, clock out. So here in this 40 pin 8085 microprocessor diagram, I have marked this power supply and frequency signal pins, that is X1, X2, VCC, clock out and VSS. So start with what is VCC, what do we apply in this pin? Actually for the operation of the microprocessor we need a power supply. So a single plus 5 volt, again I am repeating, a plus 5 volt power supply is given to the pin VCC. Then comes VSS. VSS, here we give the ground. Then X1 and X2. So a tuned circuit like LC, RC or crystal is connected at these two pins. The internal clock generator divides oscillator frequency by 2, therefore to operate a system at 3 MHz. Therefore, to operate a system at 3 MHz, the crystal of tuned circuit must have a frequency of 6 MHz. So, in short, I can say X1 and X2 are the terminals to be connected to an external crystal oscillator which drives an internal circuitry of the microprocessor to produce a suitable clock for its operation, that is for the operation of microprocessor. Next is clock out. So this signal is used as a system clock for other devices. Its frequency is half the oscillator frequency. So I have covered every pin of this classification, power supply and frequency signals. Next classification of the pin is data bus and address bus. So start with the data bus and address bus. In under this classification we have the pins A8 to A15, which is called higher order address bus, and AD0 to AD7, which is called low order address bus and data bus. So what these buses are used for? As I have already told you, if the microprocessor wants to access any memory location, that is any memory location outside the microprocessor, we know the memory is located outside the microprocessor, and in that memory, if microprocessor wants to access any memory location, since the memory location is having 16-bit addresses, so it will give that 16-bit address to the memory. Microprocessor will send 16-bit address to the memory. So how this 16-bit address is going to get sent from microprocessor to the memory. That will be from address bus. So the address bus is from A0 to A15, but it is divided into two parts. That is A0 to A7 is multiplexed with data bus, that is designated as AD0 to AD7, and the higher order A8 to A15 will carry the higher part of the address. So again I am repeating, that is the upper half of the 16-bit address appears on the address lines A8 to A15. These lines are exclusively used for most significant 8 bits of the 16-bit address lines, and as well as it is also used for 8 bits of the input-output address. Whereas AD0 to AD7, the 8-bit data bus, that is D0 to D7, is multiplexed with lower half, that is A0 to A7 of the 16-bit address bus. So during the initial part of the instruction execution, lower 8 bits of memory address or input output address appear on these address lines, that is AD0 to AD7, and during the remaining part of the instruction execution, these lines are used as bidirectional data bus. Therefore AD0 to AD7 will work as address bus as well as data bus. In the initial part it will work as address bus, and the remaining part it will work as bidirectional data bus. So this is multiplexed. So this was all about data bus and address bus. The next classification of the pins is control and status signal pins. So under control and status signal pins, we have ALE, RD bar and WR bar, IO/M bar, S0 and S1, and ready. So I have shown all these pins here, that is ALE, RD bar, WR bar, S0, S1, IO/M bar, and ready. So what is ALE? ALE is address latch enable. As I've told you that AD0 to AD7 lines are multiplexed, and the lower half of address, that is A0 to A7, is available only during the initial part of the instruction execution. This lower half of address is also necessary during the remaining part of the instruction execution to access specific location in memory or input-output port. Now this means that the lower half of the address must be latched in the initial part of the instruction execution so that it is available throughout the machine cycle. So the latching of lower half of address bus is done by using external latch and ALE signal from 8085 microprocessor. So this address latch enable, it when it is high, it actually latches the address, that is the lower bit address of the memory location which is in the line AD0 to AD7 using an external latch, and then those AD0 to AD7 lines get free for the transferring of data through these lines. The next is RD bar and WR bar signal. Since RD and there is a bar sign over it, this means this pin will get activated when a low is on this pin. When a low occurs on this pin, that is 0, logic 0, when logic 0 occurs on this pin, then it is activated because a bar sign is there, RD bar. If only RD had been written, then it would get activated by high. So this RD bar and WR bar signals are basically used to control the direction of the data flow between processor and memory or input output device or port. A low on RD bar indicates that data must be read from the selected memory location. A low on RD bar, again I am repeating, a low on RD bar means that pin is activated, read operation has to be done, and data must be read from the selected memory location or input output port. Whereas a low on WR bar pin indicates that data must be written into the selected memory location or input output port. So whenever RD bar pin is low, then data will get it means the read signal and the data will get transferred from the memory location to the microprocessor through this data bus, that is AD0 to AD7. And when we have WR bar signal low, means WR bar pin gets activated and the data gets transferred from microprocessor to the memory location or input output port, whichever the microprocessor is accessing through this AD0 to AD7 lines. So we'll continue in the next lecture. I am ending this class here.